Okay, seventh period. So we are going to start with this little single sheet. These are going to help you finish last time's homework. And then we are going to move on to your related rates packet. We're not going to finish it today, but we're going to work on that packet over 2 days. So we're going to start right here. Okay, these are questions just like the second implicit homework. Okay, so let's start with number 13. You are given a relation, and then you're given the derivative. So, oops, normally you would have to take this derivative yourself, but they've already given you the answer. Okay, then it says to find all the coordinate points where x is 1, where the tangent line is horizontal. Okay, so for horizontal, you want to set the top equal to 0. Okay, you should know that from last time's notes. So let's take our derivative and take the top. We're going to set it equal to 0. So that'd be negative y. Is that what it is? Yeah. Minus 2x equals 0. Okay, from there, we want to use this as a substitution to go into the original. So I'm going to pick which of these letters would be easier for me to solve for. So it's going to be the y, just since it doesn't already have a number on it. So negative 2x can be used to replace y. And then that substitution is going to happen back here in the original equation. So I'm going to come over here to this guy. Anywhere that I have a y, I'm going to put a negative 2x. So let's do it. So it's an x squared plus 3. Negative x times y, and then when I get to the y, I'm plugging in a negative 2x. Then I have another minus y here. So I'm going to minus another negative 2x. Okay, from there, we are going to just kind of simplify that a little bit. So I have x squared plus 3. And then negative x multiplied by a negative 2x would be a plus 2x squared. And then minus a negative 2x here, that would go to a plus 2x. Now, you should be able to tell that this is quadratic, because not only do you have x squareds, but you also have regular x's as well. So our plan is going to be to get all the x stuff on the same side equal to 0 so we can AC chart it. So I'm going to minus this x squared across from the 2x squared. So that would give me 3 equals 2x squared, take away an x squared is x squared plus 2x. And then remember, everything has to be on the same side. So that means that this 3 is going to have to subtract across as well. Okay, because remember, you can only AC chart if it's equal to 0. So from there, ABC, we are looking for numbers that will multiply to negative 3 and subtract to positive 2. So the only combo that will times to 3 is 1 times 3. And I'm going to put the minus on the smaller side so that my 2 at the bottom can stay positive. So we have an x minus 1 and an x plus 3. Okay, from there, we're going to solve. Remember, your solutions are always the opposite of what you have in your factor. So if it's an x minus 1, that means x equals positive 1. And a plus 3 means x equals negative 3. So my graph is going to be horizontal for any point where my x is a 1 and any point where my x is a negative 3. Then it tells me to find the points, not just to describe them. So if I'm wanting to find the coordinates, this information is not enough. To find the second half of the point, I'm going to have to use this equation right here. So if my x is a 1, then I automatically know based on this equation that my y is going to be negative 2 times that x, which is a negative 2. So the ordered pair that I would want would be 1, negative 2. Now, 1 wasn't my only answer. I also got a -3 answer. So if my x is a -3, that means my y is -2 times -3, which means my y is a 6. So my second ordered pair would be -3, comma 6. Okay, so technically there are 2 points where this is going to come out horizontal. Now, if you type both of these points into your delta math, it's going to count it wrong. And the reason why is because it only says to find the points where the x is a 1. So when you're typing into delta math, out of these 2 solutions that we got, you would pick the one where your x is a 1. So that would be the answer that you would type in for your homework. The reason I'm having you work it out though fully is because on the AP test, usually if there are multiple points, they would want you to find all of them. So delta math is specifically choosing one of those 2 ordered pairs, but really for AP, you should be prepared to find both. Okay? All right, let's do the next one. So we have a whole relation here. You'll notice that they have already taken the derivative for you. And then they're asking you to find the coordinate points where the tangent line is vertical. Now, remember, for horizontal, you're letting the top equal to 0, but for vertical, you're going to let the bottom equal 0. So in this case, the bottom of my equation is an x minus 2y. We're going to let that equal 0. Then remember, I can solve for x or y, but I want to pick the one that's going to be easier. So in this case, since my x doesn't have a number on it, I'm going to solve for that. So it'd be x equals, just push this guy across. Now it's a positive 2y. And then remember that I can use that as a substitution back into my original relationship here. Okay. So we're going to go bloop, right there. So my xy minus 3, I'm going to replace the x with a 2y times the extra y minus 3. Then I have a minus, and x is now being replaced with a 2y minus y squared equal to 0. Then from there, you're going to combine any like terms and work it down just like we did on number 13. So 2y times y would be 2y squared minus 2y minus y squared equals 0. We're looking for our like terms. So if I have a 2y squared minus a y squared, that'd be 1y squared minus 3 minus 2y. And then at this point, you should be able to recognize that's a quadratic. We're going to have to factor it. Now, typically you would want those terms to be in order. So we're going to do the y squared first, then the minus 2y, then the minus 3, so that we can AC chart it. So this is 1 times -3 is a -3 on top and a -2 on bottom. The only multipliers for 3 are 1 and 3, but since I am wanting to keep a negative in the bottom of my AC chart, this time we'll put the negative on the 3 side. So then my factors will be y plus 1 and y minus 3. Okay, then from there, we know our solutions will be the reverse. So y could be -1 or it could be 3. Now, if it's wanting a description, just giving y values is fine. But since it is asking you to actually find the coordinate points, we need x's and y's together. So now that I have these 2 values, I'm going to go back to my substitution step and find what x's would go with that. So if my y is a -1, then I know my x is 2 times that, which means my x is a -2. So that ordered pair would be, remember, it's always x then y, so it'd be -2, -1. for my first point. My other y option is a 3. And if I plug in my 3 here, 3 times the 2 in front would give me an x of 6. Which means that my second ordered pair would be 6, 3. Okay. Remember, for AP, they would probably want both of these as your answer. But for this question, it's only wanting the one where your y is a -1. So that would be this. Okay, but remember, technically there are 2 answers where it's vertical. Delta math is really just only wanting a specific point rather than both of them. Okay? All right, second thing that we're going to do, just for you to be able to finish your homework from last time, go ahead and turn the page, is we're going to work a couple of level 3s. I think we skipped those last time. So go ahead and turn the page. We're going to start with the one on the bottom. So you're given a relation here. And you're asked to find the slope or the dy dx. So remember, finding the slope, that just means take the derivative, basically. So if I'm looking at this first equation here, I notice that this is going to need chain rule. Okay, the reason I know that it needs chain rule is because it's a 3x minus y on my inside layer, and then all of that is raised to the power of 5. So let's take the derivative. I'm going to do the 5 power first. So to take the derivative of a 5th power, the 5 comes down to the front. Your 3x minus y is going to stay the same. But I'm going to reduce the power by 1. So after I pull the 5 down to the front, now it's a 4th power. Okay, then chain rule says I keep the 3x minus y layer the same, but then I multiply its derivative behind it. So I now need to take the derivative of the 3x minus y, and I'm going to multiply it right here. So 3x minus y is going to go to a 3. And then the minus y is going to go to a dy dx. So this piece here is the derivative of the core piece here. Because remember, you just have to go layer by layer. Okay, then equal to, on the other side, we have an e to the 4x. Remember, e to the 4x is its own derivative. But then when you go in a layer, the derivative of the 4x part would be an extra times 4. Okay, then remember, here's essentially what we're trying to do. We really want to get this dy dx by itself, but you'll notice that it's like kind of tied up in these parentheses. So what you're going to do to get rid of these parentheses is that you're going to take this from the outside and you're going to distribute it in. So for a second, this is going to get a little bit worse before it gets better. So my 3x minus y to the 4 is going to times by 3. So 5 times 3, now that's a 15. And then the 3x minus y to the 4th is going to come with it. Okay, next, I'm going to take that term and I'm going to times it by the minus dy dx. So it's a minus 5 3x minus y to the 4th dy dx. Now, you might be thinking, well, that seems worse because now I had to write this in 2 different spots. Because remember, we distributed it. Okay, but the reason that this is better is that now my dy dx is not inside this parentheses anymore. So I can essentially move the term that doesn't have the dy dx across to the other side and then divide by whatever's in front of it. So what I mean by that is that this term is going to have to cross and turn negative. So we'll have e to the 4x times 4 minus 15 3x minus y to the 4th. And then out of this part, Okay, and then out of this part, this front piece, since it's multiplied with the dy dx, we're gonna divide it to the bottom. So I'll divide this here, and I'll divide it here. Okay, now, some of y'all are gonna wanna try to start canceling stuff out, just don't. Okay, this 3x minus y to the fourth cannot cross out with this 3x minus y to the fourth because there's more stuff on top. So just basically what I would say is for the level threes, just don't try to simplify it a whole bunch. Just type it in like it is. It's gonna have some kind of seemingly repetitive stuff, but you can't cross it out. And if you want an explanation on that, I'm happy to help you with that another time. Okay, I think we're just gonna do one more from the level 3 page, so let's do number 16. Okay? All right, so you are given an equation and you're asked to find the slope. Okay, so the first thing that I notice is that my outside layer is a sine. So the derivative of sine is going to go to cosine. And then I'm going to keep the 3x squared y4 the same. But I'm going to have to multiply its derivative behind it. So remember, the sine layer goes to cosine. The middle part stays the same, but now I'm going to multiply its derivative at the back. Okay, when you take the derivative of this centerpiece, you should notice that it's going to need product rule. And the reason why is because it's x and y stuff and it's multiplied together. So up here at the top, I'm going to write my pieces. My u is a 3x squared. And my v is a y4. So take the derivative of those. So 3x squared would go to 6x. And then for your y to the 4, derivative would go to 4y cubed. But then don't forget, because it was a y, you have to attach a dy dx. Okay? Then from there, remember, it's derivative plus derivative. Or sorry, diagonal plus diagonal. So I'm going to do this one first. Plus. And then for this second diagonal, the 3 and the 4, I'm going to just times those pieces together. So the 3 times 4 is going to be in 12. And then x squared, y3, okay. Then from there, it's equal to a 9x. Derivative of 9x is just 9. Okay, and then we see why this is classified as a level 3. I want my dy dx by itself, but I see that it's kind of like tangled up in this parentheses situation. So we're going to do exactly what we did last time. Okay, we're going to circle what's on the outside, the cosine 3x squared y4. And we're going to have to distribute that into both of the terms on the inside so that those parentheses are gone. And remember, it gets a little bit worse before it gets better. So your cosine 3x squared y4 is going to times by this first. Yeah, go ahead. And then you're going to carry that same cosine 3x squared y4 into the 12x squared y cubed dy dx. Okay. Then from there, even though it kind of looks worse that it's like, oh no, now this cosine is here twice. What makes it better is that without these parentheses, now I can just pull one of them across on top and then divide the other one to the bottom. So this term here that does not have the dy dx is going to subtract across behind the 9. So it'll be a 9 minus cosine 3x squared y4, 6x y4. And then after I push this term across, all of this junk is going to end up divided to the bottom. So your final answer would be like this. And then your dy dx would just stay. Okay. So kind of give yourself a minute to process that. Think about if that makes sense. That for the level 3s, you're going to distribute what's on the outside to get rid of those parentheses so that you can pull the non-dy dx term across and then divide the other term to the bottom. Okay? You're okay. I'm just doing a video. You're fine.
Could I get
Yeah, mark it out.
Can I get the 80 calculus notes and sister?
Yes, your inverse
Yep.
brother. Yeah, let me grab her. You okay?
Yeah, she's okay. She was just a little sick. It sounds like a stomach bug.
Your future captain's actually.
That's why you lying. That's not lying. To me.
I don't know about that.
These are the ones for tomorrow. Then I emailed her back that the other notes that we did yesterday are a package she should already. Okay, thank you. Tell her I hope she feels better.
Bye.
All right. So now we're going to transition into, so you should be able to finish your homework from last time if you needed help with that. But we're going to add related rates is the last thing that we're going to cover before Thanksgiving. These are kind of weird, but we're only going to intro to them today, and then we're going to continue with this same packet of notes last time. So implicit differentiation, which is what we have been doing, is where you take the derivative with respect to x. Related rates, you're going to be taking the derivative with respect to time. Okay, and so essentially here's what that means. Normally when you take the derivative with respect to x, anything that's an x, you don't have to add any extra stuff to, but if it's like a y, you would have to add a dy dx. If you're taking the derivative with respect to time, then any letter is going to get a ddt of that letter. So let me kind of show you what I mean. Okay, take a look at this first one here. We're going to take the derivative of that. Okay, but remember, we're taking the derivative with respect to time. So the letters that I'm writing here are ddt, which stands for time. So rather than ddx, which we've been doing, ddt is the derivative we're taking here. So every letter that's not a t, you're going to add a d letter dt for that. So for example, if it's an x3, the derivative of that would go to a 3x squared dx dt. Yeah. So essentially your x just no longer gets a free pass on the derivative process. Okay, then for my negative 2xy, hopefully you know we're going to need product rule for that. So my u is a negative 2x, my v is a y. U prime would be the derivative of negative 2x, which is a negative 2. But then you have to attach a dx dt, because remember, no more free passes for the x stuff. Okay, then your v. Normally we'd put the derivative of y would be 1 dy dx, but now it's a 1 dy dt. Did I do that?
No, I didn't.
Oh.
But I was doing my math.
Oh, okay. Then from there, you're going to do diagonal plus diagonal. So it'll be negative 2 dx dty. And then negative 2x dy dt. Okay. Then on the other side, we had an equals x squared. And from there, the derivative would just be a 2x, but remember, no more free ride for the x stuff. You have to now add a dx dt to that. Okay? All right, then we are gonna just skip the next step where you'd be plugging stuff in. So let's just go on to the next one and give it a shot. Okay, so this is the derivative of that. Okay, but you're not gonna have to like solve it the way that we were doing with the dx dt, the dy dx's. All right, so one more. We have an x3 e to the 2y times 8. We want to take the derivative of that. So first thing you should notice is that you are going to need product rule. Because you have x's and y's that are multiplied together. So your u is an x cubed. Your v is an e to the 2y. And then we're going to take the derivative of both of those pieces. So an x cubed derivative would go to 3x squared. But then remember, no more free passes for the x's. We're going to have to attach a dx dt because we're taking the derivative with respect to time, not the derivative with respect to x. For your v, it was an e to the 2y. So it's going to be e to the 2y again. But then when you move in a layer after the e part, the derivative of just the 2y is an extra times 2 dy dt. Okay, then from there, you're going to do your diagonals plus to each other. So it'd be a 3x squared dx dt times an e to the 2y. Plus, and then an x3 e to the 2y times 2 dy dt. Now, on the other side, you'll notice that you just had an 8. So since 8 is a constant, your derivative for that would just still go to 0. Okay. All right, so as of right now, that's all you have to do. Okay, so go ahead and turn the page. So here's what's going to happen. When you turn the page, you're going to see a lot of relationships that you learned in geometry. Okay, so let's just take a little walk down memory lane here. So when you were in geometry, you did surface area, you did volume, you did regular area for cylinders, for circles, right triangles. So all of these are formulas that you've seen before. And what we're going to do is we're now going to take the derivative of those with respect to time. Okay. So find the formula for volume of a cube. The volume of a cube is here. We're going to practice taking the derivative of that with respect to time. So put V equals L cubed. And then we're going to take the derivative of that with respect to time. So put d dt. Okay, when you take the derivative of volume, the derivative of volume would just be a 1, but then we have to attach a dv dt. Okay, on the other side, I have an L cubed. So derivative of that would be 3L squared. And then I have to attach a dl dt. Okay, and then you're done. You took the derivative. Okay. Next one we want to do is area of a circle. I see area of a circle is right here. We're just picking a couple of these. So area equals pi r squared. And we want to take the derivative of that, but with respect to time. Okay. So the derivative of A would just go to a 1. Because remember, if you take the derivative of like an X, it would just be a 1 as well. So it'd be 1 dA dt. And then for the formula side, my squared would times down on my pi. So 2 times pi is a 2 pi. My R squared is gonna drop to a regular R because I have to power it down. And then attach a DRET. And you're done. Okay, one more like that. We want surface area for a sphere. That formula is right here. So area equals 4 pi R squared. And then we want to take the derivative of that with respect to time. So the derivative of A would go to a dAdt. And then on this side, we're still taking the derivative, but now my 2 is going to times by my 4 pi. 2 times 4 pi is an 8 pi. Then I would drop the R squared down to a regular R and okay, we're just gonna do one more. Let's do area of a rectangle. So area of a rectangle, hopefully we all remember. Area is length times width. And we want to take the derivative of that with respect to time. So the derivative of A would go to dAdt. But then when I take the derivative of the LW side, since the L and the W are multiplied, you would have to use product rule. Okay, so this is gonna need product rule. Because you have L's and W's and they're multiplied together, just like if you had X's and Y's and those were multiplied. So my U is an L, my V is a W. We're gonna take the derivative of both of those and then cross product. So L, the derivative is dL dt. And then W, the derivative would be dW dt. Okay, then from there, this plus that. So it'd be L dW dt plus W dL dt. Okay. So as far as right now, what you should be able to do is take the derivative with respect to time for any of the equations on this page. Some of them will need product rule, some of them don't. Okay. All right. So we're going to add kind of one more layer to this, and then you should have enough practice with it to do all of, I would say most of your homework on related rate. So turn the page. Okay, so what we're gonna do now is we're gonna take these rates that you've been looking at and we're gonna have them applied within the context of a real world scenario. Okay, so you're gonna read what the sentence says and then turn it into a related rate. So here's what I mean by that. Okay, number 1 says the volume of a cylinder is increasing at a rate of 5 cubic meters per second. So if you know how fast the volume is changing, we're going to call that dV dt. Okay, then it specifically tells me that that volume is increasing. So it's going to be equal to a positive number. And specifically, it's increasing at a rate of 5 cubic meters per second. So the way that you would write cubic meters per second is meters cubed per second. Okay. Let's take a look at the next one. This time, the quantity that we're talking about is the height of water in a pool. So if I'm talking about how fast the height of water in a pool is changing, I'm going to call that dH dt. Okay, and then it tells me that the height of the water in the pool is decreasing. So remember, decreasing means that it's equal to a negative value. And then it says it's 2 inches per minute. So it'd be negative 2 inches per minute. All right, we're going to skip 3 and go on to 4. Okay, for 4, it says the air in a balloon is escaping at a rate of 15 cubic centimeters per second. So the air in a balloon, think about what that's a measurement of. if you're measuring how much air fits in a balloon, that would be volume. And then it tells me that the air in the balloon is escaping. So think about, is that a increasing rate or a decreasing rate? So if the air is escaping from the balloon, that would be decreasing. Okay, and then it says it's 15 cubic centimeters per second. Hey, centimeters per second. Okay. All right, so now we're gonna do 3 examples. Okay, you can do it. Hang in there. You're almost done. All right, so the way that we're gonna work these word problems is we're gonna start off by identifying what we're trying to find. What you're given. Usually you're gonna have a when. And then what equation you're gonna use off of that page of formulas. Okay. So we're gonna read through the question and then we're gonna look for those pieces. What are we trying to find? What rate are we given? What moment in time do I care about? And then we'll pick an equation off the list. So it says a pebble drops into a pond, causing ripples in the form of concentric circles. The radius r of the outer ripple increases at a rate of 3 feet per second. When the radius of the outer ripple is 4 feet, at what rate is the area of the outer circle of water changing? So let's start with the find. Let's look at our question. We want to know what rate the area is changing. So I'm going to call that dAdt. Okay, and that stands for how fast the area is changing. Your given should be how fast something else is changing. So I'm going to read you this sentence right here. It says the radius of the outer ripple is increasing at a rate of 3 feet per second. So the radius would be dr dt. And then it says it's increasing, so it's equal to a positive value, and then specifically 3. Okay, feet per second. Then my when is going to be a certain quantity for something that's changing. So what I mean by that is it says when the radius of the ripple is 4 feet, that would be r equals 4. Okay, but remember the radius isn't always 4. That's just like the moment that I want to essentially like take the snapshot, if you will. Okay, so this is the area of a circle. And this is the radius of a circle. So I want to look on my formula chart for an equation that connects the area of a circle to the radius of the circle. So go ahead and peek back if you need to. Okay, the area of a circle is going to be this formula right here. No, what's up?
Oh, I just think you have to know.
Okay, that's fine. Thanks. So my equation is A equals pi r squared. Okay, after you identify your equation, you're going to take the derivative, which we actually already practiced this. My A goes to a dAdt. And then for my pi r squared, the 2 comes down, so now it's a 2 pi in the front. My r squared drops to a regular r, and then I have to attach a dr dt. Okay. Then from there, all you're going to do is plug this crap in and solve for the dAdt. So I have dAdt equals 2 pi r, and I see that my r is a 4. And then my dr dt is a 3. So then from there, I would say, okay, well then 2 pi times 4, that would be 8 pi. And then times 3, that's a 24 pi. Okay. Now, let's say that you wanted to talk about units in your answer. Delta Math doesn't really ask you to do this, but the AP test will. That your R was 4 feet. And then your 3 was feet per second. So if you multiply those units together, feet times feet would be feet squared. And then seconds on the bottom. So essentially, if you were gonna describe what that is, you would say that what that means is that the area is increasing at a rate of 24 pi square feet per second. Okay, and that should make sense that anytime that you're measuring area, since you have like a length and a width, usually feet squared or square feet is how you would measure that. Okay? All right, we're gonna work 2 more questions. So you're almost done. Go ahead and turn the page. And we're gonna do number 3. Okay? Number 3. So we're gonna set up our find, our given, our when, and then our equation. And sorry, I didn't give you as much space on this question as I normally would. Okay, so it says at the width of a rectangle is increasing at a rate of 6 centimeters per second. The length is decreasing at a rate of 3 centimeters per second. At what rate is the perimeter changing? So our question tells us what we're trying to find. We want the rate that perimeter is changing. We're gonna call that dp/dt. Okay, P standing for perimeter. Okay, then our given, it says the width of the rectangle is increasing. So that means dw dt is equal to a positive value. Okay, and then it says specifically that it's increasing at a rate of 6 centimeters per second. Okay, my second sentence says that the length of the rectangle is decreasing at a rate of 3. So that means that my dl dt would be a negative 3 centimeters per second. Now, this question doesn't really give me a when, so I'm just gonna cross it out. Sometimes you'll have a when, sometimes you won't. So in this case, they didn't ever say when, so we're just gonna skip it. Okay, then for my equation, I need something that relates the perimeter of a rectangle to the length and the width of the rectangle. So if you kind of peek back at your little formula sheet, okay, you should see that the perimeter of a rectangle is 2L plus 2W. Okay. So perimeter equals 2L plus 2W. Now we're going to take the derivative. So P would go to dp dt. 2L, the derivative would just be a 2, but then we have to attach a dl dt. And then 2W would be kind of the same thing. Your 2W would go to a 2 dw dt. Then from there, you're just going to plug in your different values. So my dl dt, I'm going to put a negative 3 here. So that'd be 2 times negative 3. Plus 2 times dw dt would be the 6. So that'd be negative 6 plus 12. Negative 6 plus 12 is 6. So the perimeter is changing at a rate of 6. Now let's talk about units. Remember, dl dt and dw dt were both centimeters per second.
I've seen that, bro.
And centimeters per second. But think about that if these are both centimeters per second and I add them together, that's going to keep my units at centimeters per second. Okay, because I'm not multiplying those pieces together, I'm adding them. So you can only add like units, so your units would stay the same. So if you were to write like a little sentence there, you would say the perimeter is increasing at a rate of 6 centimeters per second. Okay. And that would be your answer to part A. Okay? All right, now let's do part B. So same rectangle. So I'm not going to rewrite the given part because that's the same. But it says at what rate this time is the area of the rectangle changing? When the width is 4 and the length is 5. So my find this time is at what rate is the area changing? So I'm going to call that dAdt. And then for my given, I'm going to just put same. Jacob, you have the worst whisper voice of all time, I have to say, of all time. Okay, then for my when. Okay, it says right here, when the width is 4 and the length is 5. So width is 4 and length is 5. Okay, then my equation, I'm gonna have to pick from that sheet. So this time we're talking about area, and then this is still a rectangle. So if you want to kind of peek back to your other sheet, we want the equation for the area of a rectangle and its length times width. Okay. Now, because this is an example we already did, do you see that we already took the derivative of it here? So I'm just going to copy that work over, but you would have to do product rule. So you should kind of remember that, but since we already did it, I'm just going to snatch this equation from right here. Okay, so dAdt equals, and then it was LdW dt plus W dL dt. And then from there, we're ready to just plug our numbers in. So my length is 5 centimeters. My dW dt is 6. And it's centimeters per second. My width is 4 centimeters. And my dL dt is minus 3 centimeters per second. Okay. Then from there, your 5 times your 6 here would be a 30. And then that'd be a minus 12. And 30 plus negative 12, that would be 18. Now let's talk about units. Centimeters times centimeters per second would be squared centimeters per second. This is also squared centimeters per second. And when you add them, the square centimeters per second would stay the same. Okay. Then it does ask you in this question at the end if the area is increasing or decreasing. So because this dAdt at the end came out positive, we know that the area overall is increasing. Okay, if your rate comes out negative, that means overall the area is decreasing, versus if it comes out to be a positive number, overall it was increasing. Okay. All right, very last question we're gonna do is number 4 off the next page. So if you'll turn the page, number 4, set up your find, given, when, and your equation. All right, so it says the base of a triangle is increasing at a rate of 6 inches per minute, while the height of the triangle is decreasing at 3 inches per minute. Then it says the rate that the area of the triangle is changing. Oh, wait, sorry. Find the rate that the area of the triangle is changing at the moment when the base is 12 and its area is 42. So here's my given. The base of the triangle is increasing at a rate of 6. We're going to call that dB dt. Then it says the height of the triangle is decreasing, so that'd be DHDT equal to -3. Now think about why it's a minus. It's because the height is decreasing, means it equals a negative value. Okay, then it says find the rate that the area is changing. That would be dAdt. And then it says when the base is 12 and the area is 42. So for my when, I'm going to put my base needs to be 12 and my area needs to be 42. Okay, then we need to find our area formula. So if you'll just kind of peek back at that page, remember we're talking about a triangle this time. So we're looking up the area of a triangle formula, okay, off of our sheet on the back of the first page. Okay. So area of a triangle, you should be able to see it here. So write that down. Area equals 1/2 base times height. All right, then if I want to take the derivative of that, the first thing that you should notice is that this piece here is going to require product rule. Okay, so just kind of always watch out for that, that if you have X's and Y's that are multiplied, you need product rule. Okay, same story for related rates. If it's a B and an H multiplied, you need product rule as well. So let's write our derivative. A is going to go to dAdt. And then we're going to have to work out our product rule kind of down here at the bottom. So my U is a 1/2 B. My V is an H. Okay, because we're doing product rule on that. So 1/2 B, the derivative would go to 1/2, but then you have to attach the dBdt. Okay, then my V prime would be the derivative of H, which would just go to a dHdt. And then remember, it's diagonal plus diagonal. So this plus this. So I'll write this one first, I guess. So it'll be 1/2 B dHdt plus, and then this diagonal will be 1/2 dBdt times H. Okay. And then we're just going to plug in our numbers from there. So dAdt equals 1/2. My B is a 12. My dHdt is a -3. Plus 1/2. My dBdt is a 6. And then when I get to H, I notice that I actually wasn't ever given H. So that's going to be a little bit of a problem. Look at the information they gave you instead. They told me the base is 12. And instead of telling me the height that goes with that, they told me the answer for area. Well, then that actually, if I kind of work my way backwards, will let me find H. So let's think about, if I know area is 1/2 base times height, and I know my area is 42, then that would have to equal 1/2 of my base times height. And then keep in mind that I know my base is a 12. So then 42 equals 1/2 of 12 would be a 6 times H. Well, then I know that my H has to be 7. Because 6 times 7 is what would give you the 42. So then now I know that that has to go there. Then from there, we're going to multiply. So 1/2 of 12 would be 6 times -3 is a -18. 1/2 of 6 here would be a 3. 3 times 7 is a 21. And then -18 plus 21 would be 3. Now, let's say that you wanted to talk about units. This is a measurement of area. So I know that if my base and height were measured in inches per minute, then I know that my area would be inches squared per minute. Okay. So I know that my area is increasing at a rate of 3 square inches per minute. All right, so we are gonna do harder examples of this next time, but that should really be enough information for you to kind of start today's homework if you don't need extra time to go back and do last time's homework. Okay? Good luck, you can do it.